Hello and welcome to week 2 of this course on interaction design. Let us begin this week by doing a quick recap of what we have already learned about the course. So we began by raising certain interesting questions. The first question that we raised was, what is an interface? And then we followed up this question with other questions like what is interaction and how do we define the interaction design process. So in the first session we had three different questions that we were trying to answer. As part of question 1, which was what is interface, we had seen interface as a medium to communicate between two different black boxes. The first one being the machine or the computer and the other one being the human being. In absence of this interface, there is absolutely no possibility of communication between the computer and the human being. We have also learned that interface is about representation of surfaces, because if you remember the first phrase that we were dealing in terms of interface, it's a surface between two surfaces. And we had modified that phrase of a surface between two surfaces by understanding that representation of the surfaces play a crucial role. So interface is not just about surfaces, it is about how do you represent those two distinctly different surfaces. And then we had the second question where we were raising what is interaction, and we understood it across a historical timeline, where in 1901 it was understood in terms of reciprocity, and then later in 1960s we started understanding it as a symbiotic relationship between the computer and the user. And later on, it evolved into an understanding of kind of a communication between the user and the computing artifact. So we had also advanced our understanding of interactions. Then later on in the session, we had understood that how interaction design is a goal-driven exercise. And that's where we moved on to session 2 in the last week, where we had seen relevance of goals in the interaction design process. We had also paid attention to typical setups in a professional environment like a company or in an organization or in a design studio where interactive products gets developed or designed. So we were aware of typical team members, their roles, responsibilities, and goals in the interface and interaction design processes. We have also paid attention to typical reasons why interactive artifacts succeed or fail. And we have also given a lot of emphasis on understanding user goals and user tasks and how both of these things are different. That was the mid half of the last week. Later in the week, we had understood certain concepts around implementation or system model. Then we had understood what is a mental model, represented model, and a part of discussion on affordance was also carried out. Now in week 2, we are going to keep some of these concepts along with us and move forward to further increase our understanding of interaction design. The concepts we are taking forward are around the mental model and the implementation model. And if you remember this continuum, which we had shown in the last session, that on one side of the continuum or the scale was the mental model, while on other side of the continuum was the implementation model. I hope you remember this slide from the last session. So this was the implementation model. And in between these two models were 3 or 4 different variants. Let us draw those again. Okay, and we were calling these, all of these, represented or designed model. And if you remember, when we were talking about mandate of an interaction designer, we were saying that while the interaction designer is conceptualizing interactions and the represented model, the mandate is that the represented model should be close to the mental model of the user and not the other way around, because if it goes close to implementation model, it may fail due to several reasons. So while you are designing an interactive product and you are thinking about represented model, you are thinking about different interactions which are possible, you must think about mental models, and your goal is, as a design team member or a designer himself, is to go as close as possible to the mental model. Now here comes one interesting question. How do we conceptualize these different models? So if you recall, these models are about the interactions, which is about how the interactive product, what does it do, which is about what does the interactive product do, how does it behave, and how does it look. So if you remember, these represented models are about the interactive artifact, and there three different questions are important. That what does the artifact do, how does it behave, and how does it look. So it is very important to have some assistance, have some inspiration in terms of conceptualizing these different represented models. And that's where the topic of this week becomes highly relevant. This week we are going to deal with interaction model and interaction paradigms. Let us first begin by knowing what an interaction model is. So if you look at your screen, you will find that an interaction model is an operational description of how interaction proceeds. Since it helps conceptualize interactions, it is also known as conceptual models in many of the books. And if you remember that continuum where you had mental model at one place and implementation model at another place, and there are so many represented models in between, you will get a sense that designing or conceptualizing the represented model is a highly iterative process. And every time you create an iteration, it's better to test it and then improve further on that iteration. So interaction model gets refined through iterations and testing. Let us find a more nuanced understanding of interaction model. It says, a description of the proposed system in terms of a set of integrated ideas and concepts about what it should do, behave, and look like, that will be understandable by the users in the manner intended. Now, when we say that it is about the proposed system, that's what we mean by it is about the proposed represented model. It is about the proposed interactive artifact, how that interactive artifact, what it should do, how it should behave, and how does it look like. And all of these three different treatments about its objective, about its behavior, and about its look and feel, all of these three different treatments by the designers have to be accomplished in such a way so that they are understood, they are easily understood by the users in the manner intended. While there are many kinds of interaction model, we come across two main categories. And also, if you see that these models keep evolving, a lot of people who are researching into the domain of human-computer interaction and interaction design, they keep proposing new models. But essentially, if you see, there are two main categories. The first one is based on activities, and the other one is based on objects. Now let us see few interaction models which are based on activities. So you have four different interaction models which are based on four different activities, or you can say group of activities. Okay, so the first group of activities involves instructing the computing machine or instructing the interactive artifact. That is the first set of activity. The another set of activity involved getting in conversation with the interactive artifact. So that is the second set of activity. That's what we are calling conversing. The third set of activity involved manipulating and navigating through the interactive artifact. Okay, so manipulating the objects and navigating to the virtual spaces is the third set of activities that results in a different kind of interaction model. And the fourth set of activity is about exploring and browsing. So you see that we have in this categorization different set of activities which are resulting different set of interaction models. First, let us look at the set of activities which are about instructing the interactive artifact. So in this set of activities, what is covered is the following, where users instruct the system to perform the task of their interest. They are different from task delegation. Let us read through some of these activities. For example, if you were to print the document and if you were to ask time from your mobile phone, if you were to read the news, and if you were to initiate an activity based on a certain pre-specified timetable like reminders or notifications, and if you were to read text from the screen, all of these activities can be performed by instructing the computer, by instructing the computationally empowered interactive artifact. That was the first definition, if you remember. So all of these activities can be performed by instructing, by issuing instructions to the interactive artifact. Okay, and they are much different from task delegation. You're not really delegating the task. You are instructing the artifact itself to perform the task. So it is very much different from task delegation. Most of the students get confused between issuing instructions or delegating the task. So that's why there is an explicit mention of the fact that it is very much different from task delegation. Now, what does it result? It results in command-based applications and tasks. And there are several which are listed on the slide for your convenience. So, for example, word processing and formatting, word count, counting first few registrations. Often it happens that you were to reply to a call for registration and first few numbers are either early bird registrations or there is some discount. So all of these tasks, counting first few registrations, deadline management, email filters, pictures, slideshows, copy and paste, open link in a new tab, use already added passenger details, deliver to a pre-specified objects, arrange as type, frequency or size. You might have done this most of the time on your desktop when you're trying to organize several of those files which are there in your document folder. At times you might have issued instruction to the computer saying, you arrange all my files on the basis of the type. And the result is that your folders get arranged first and then followed by your Word documents, followed by your text files, and followed by your music. So it is one such task where you are instructing the interactive artifact or the computer itself to do that task, to perform that task for you. So what are the benefits of interaction model, which is based on instructing, or set of activities which are about issuing instructions to the computer? What are the benefits? We have the following benefits. It is known to deliver quick and efficient interactions. You must have noticed yourself that there are often almost non-noticeable occurrences of errors when you are categorizing things or when you are organizing your files by issuing commands to the computer. And it is very important, it is very efficient in terms of handling repetitive tasks which involve multiple objects. So example could be filter all your email messages with the tag nptel and then move to the folder nptel. You might have been receiving emails from nptel, and if you were to across all your emails, which are like multiple objects, if you were to perform a task like filtering, that comes under the interaction model, which is based on an activity like instructing. So what are the pitfalls? Assume that the task that you are doing is pretty complex. It's not just about one-time organization of so many files. If you were to issue commands to the computer about a complex task, there would be times when you may get confused, and similar things would happen to all other possible user groups as well. So it puts heavy demands on users' short-term memory when the task that you are trying to accomplish is complex and involves a number of instructions. Under those conditions, it would put heavy demand on users' short-term memory. And in fact, if that is happening, then the entire interaction is prone to errors. Let us consider this by means of an example. What you are seeing on your screen is an automatic vending machine, which is becoming a commonplace object these days. And if you look at this vending machine, there are so many things that it can dispense. So it can dispense a packet of chips, it can dispense a huge variety of cold drinks or and other soft drinks. And then you have an entire column almost from the top of the machine towards its bottom that is about the menus, that is about the different choices that a user can make. So look at these different choices one after the other. So in the first section, what you have to do, that you have to insert a note straight into the opening, and there is a variety of note that you can insert. Then the second point is that you have to input or type the number or the code which is corresponding to the item of interest that you want to receive from the vending machine. Then the third is that if there is any change, you may want to collect the change as well. And the fourth one is pretty redundant in the sense that what it shows is just a visual where a person is consuming the item out of the dispenser. So essentially there are three different steps which have to be followed to get access to one of the many items which are kept in the dispenser. Now, even if these dispensers are becoming a commonplace object, they are pretty hard to use, because if you remember, this is about telling the computer, do this for me. And if you were to issue a number of instructions, which are at least 3 in the case of the dispenser, there are chances when users are either confused or they commit errors. We have another example as well. These days, if you move across railway stations and metro stations, you would find automatic ticket vending machines. Look at the amount of information which is pasted on those machines. Just enormous amount of information, and you are supposed to carry out a number of instructions to get a simple ticket out of these machines. So no wonder these machines also stay unused most of the time. The second model, which is based on another set of activities, is about conversing. So here the user converses with the system. User and the system, they almost talk to each other, and system acts as a dialogue partner, because it's, if they are talking to each other, there is a dialogue management happening between the system and the user. So system acts as a dialogue partner. Unlike instructing, which was the first set of interaction model, it is more a two-way communication. Remember, when it comes to instructing, you are only issuing instructions to the artifact or to the computer. You're not receiving instructions from the machine. You are receiving feedback, of course, that something is happening, and this is the time when you need to issue the second instruction. But it is pretty much a one-way communication. In case of interaction model, which are based on conversing, it becomes a two-way communication. Applications aimed at finding specific information or resolving concerns are mostly the result of such interaction models. Let me give you an example to help you understand this interaction model. What you are seeing on your screen is a natural language enabled search engine. Now, just look at the language that is being used to know about a particular topic. So what do we mean by fair use policy? It's a question which is asked in simple, plain language, and that's why it's a natural language. And instead of searching for fair use policy or something like star fair use star policy, you are actually asking the question in a very natural way, as you would have asked to any other human being. So this is a natural language conversation between the user and the search engine. And look at the response from the search engine as well. It is also responding you as if it were a human being. So it says, in most general sense, a fair use is any copying of copyright material, and so on and so forth. And then it's saying that, people are also asking about these many questions. So it's, if you look at this search result page, it is like a conversation between the user and the search engine, and the language of communication is the natural language. It's how we would have communicated with any human being. So in this particular interaction model, the set of activities that you are performing are around conversation, are around engaging into a dialogue with the computing or interactive artifact. Now, there are advantages to these interaction model as well. It enables users, especially novices. Even kids can ask very simple questions to a natural language enabled search engine. So it enables users, especially novices, to interact with the interactive artifact. You need not to be a frequent user nor an expert user. If you are interacting with computers through conversation, or interacting with the interactive artifacts, let's call it that way, through conversation. So even if you are a novice, you can use an interactive artifact very easily. And it's a simple, plain language. How do I do this? What does it mean? How does this get performed? It's a simple, plain language. All the questions that you can raise, you need not to know any special language. You can use the language that you have been using anyways. And since it is about the conversation, it can help persuade people to complete a task. Remember the case for novice user. They might not have an understanding of how does the interface work, but if the interface can talk to them, then it can persuade them, or it can lead them to the successful completion of that task. That's what we mean by when we are saying it can help persuade people to complete a task. So there are disadvantages as well. It can result in unintended delays in completing the task. Sometimes the conversation may not go as per the expectation. This happens most of the time when you are engaging in conversation with speech agents or spoken dialogue systems, basically the interfaces which are talking to you. Sometimes that conversation doesn't lead to any fruitful outcome. So it can result in unintended delays or cascading errors in completing the task. It may lead to unreasonable expectations from the interactive artifact. There is a trade-off in terms of making the interactive artifact natural, human-like, versus matching users' expectation. If you are making your machine or interactive artifact behave like human beings, then the users would also have expectations which are very much similar to what they would have with real human beings. Okay, so that's why there is a chance of mismatch in terms of expectations between the user and the interactive artifact, and it's a trade-off that we all have to balance. Error recovery may be very difficult at times. So when you have unintended delays, either the conversation is delayed with no specific direction, or users are going to commit errors during their conversation or interaction with the interactive artifact. Heavy demands on users' short-term memory if the task is complex. Again, similar thing as in case of interaction models based on instructing. And you have to issue either a number of instructions or remember or recall a number of things to complete the task. There would be heavy demand on users' short-term memory. The third interaction model in this series is based on the activities of manipulation and navigation. In this interaction model, users manipulate objects and navigate through virtual spaces as designed by the designers. So it is imperative for the designers to understand a very critical point of this interaction model: the manner of performing these activities. What are these activities? Manipulation and navigation. The manner of performing these activities may or may not reflect the real world scenario. As designers, this is a very critical point which we must be aware of. Let me illustrate this point by means of an example. What you are seeing on your screen is a hard product, is a product from the physical space. It is an equalizer. Next to it is the graphic equalizers. And you can very well see that the designer who has designed this graphic equalizer, the digital equalizer, he has literally transferred all the properties of the physical object from the physical world into the interface design of the graphic equalizer. And as we are saying that in this interaction model, I am going to move to the previous slide once again, that the manner of performing these activities of manipulation and navigation may or may not reflect the real world. So in this example where the graphic designer has chosen to design the exact replica of the physical equalizer, the manner of performing the activities of manipulation and navigation in this example is based on the real world. Let us see the other example. The other example is about when the manner of manipulation and navigation, these two activities, the manner in which these two activities get performed by the users, that particular behavior is not real replica from the physical world. So see the next example. So here once again you have the same graphic equalizer, the hard product from the physical world, and the graphic designer, instead of choosing to literally reflect the hard product from the physical world, he has done something different. He has given numbers, and the numbers can be increased or decreased, as well as the users can type this number onto the given space. And these are the same parameters, same frequencies: low, medium, high, low cut, medium frequency. So these are same parameters, but there are two different ways of designing it. And how these two designs differ? Because in one design you have an exact replica from the physical world, while in other design you have a modified version from the physical world product. One of the very interesting interaction model is direct manipulation model. It was given by Ben Schneiderman in 1983, and it has fundamental three properties. What are those properties? So, continuous representation of objects and actions of interest. So, you have a continuous representation of objects. They are visually present before you unless as a user you dismiss them. Okay? So, the screen doesn't change unless you decide that the screen should change. So, the continuous representation of objects and actions of interest that is exercised by the designers in direct manipulation interaction model. And there is an immediate feedback about the object of interest. So whatever a user does on the screen, there is an immediate feedback to his actions. Also, the user are performing these actions not by issuing commands in a particular syntax. As you would have seen in command line interfaces, you are required to issue commands by typing them in a certain syntax. That is not happening here. What is happening here? That you are, as a user, doing physical actions. So, for example, these physical actions are performed in terms of button or key presses, drag and drop, cut and copy. So, you are doing physical actions. You are not really writing commands in a particular syntax. So, these are the three fundamental properties of direct manipulation interaction model, which is given by Ben Schneiderman in 1983. Now, there are advantages that Schneiderman is proposing. It helps novice users interact with the artifact. When you are borrowing some inspiration from the physical world, novice users who are new to the machine or who are new to the interactive artifact, it brings familiarity. So they find it easy to interact with the interactive artifact. It also helps experts work with ease and speed. So these are the two different extremes when it comes to user groups. You have user groups which are about novices, and then you have user group which are of experts. So an interactive artifact, as an interaction designer, one must try to strike a right balance across this scale of expertise. Your interactive artifact should be easy for the novice users to learn and to master. It should also give shortcuts, enough affordance to expert users, enough alternate ways to expert users so that they can perform their task easily and with dexterity. Now, it should also help infrequent users utilize memory aids. So these are the three different advantages in direct manipulation interaction model. The fourth one is that it lessens requirements of error prompts. Users can see consequences of their actions. So whatever you are doing, it is happening in front of you. You are visually noticing every possible action that you are performing onto objects and different entities on the screen. And since you can see that, you can see the consequences of those actions, there is a lesser requirement to bring before you prompts and dialog boxes. Okay, so that is also one of the advantages of direct manipulation interaction model. When all of these things are happening, the fifth advantage is that users are performing their activities using this interaction model with lesser anxiety, with more confidence and control. So these are the 5 different advantages proposed by Ben Schneiderman. The fourth interaction model is based on the activities around exploring and browsing information. Many times there are interfaces which lets you just explore and browse for an information of interest. There are several examples of these interfaces. If you are looking for books, magazines, libraries, information booklets, directories, news portals, online public directories, job directories, a lot of these, the basic activities that you are performing as a user are browsing and exploring. and information of interest. So based on how users would do similar activity using other media in their physical world. So there is an attempt to draw analogies by looking at entities in the physical world as we are moving across the interaction models. This is something which I am sure you can observe right from model 1, which was based on instructing, to model 2, which was based on conversing, then on manipulating and navigating, to this model on browsing and exploring. There is an attempt to start drawing analogies from entities and different objects in the physical world. So while you are trying to design an interface which is around letting people find information, there is a need to kind of also look at how they would have done it otherwise in their physical worlds. So you must draw inferences, or you must draw inspiration from physical world when you are designing interactions which are around browsing and exploring information of interest. And when there is a lot of information, it becomes necessary to start categorizing that information. So there is a lot of emphasis which has to be paid while designing interactions in this interaction model. As you can see on your screen, there are several of these information portals and directories where there is an explicit mention of categories of different content types. And then it becomes easier for the users to find a specific information of interest. So in this interaction model, one of the major activities that an interaction designer needs to perform is information restructuring and organizing. Okay, we also call it information architecture. Categorizing information, meaningful nomenclature, linkages and interconnection across different data points is a very explicit exercise needs to be performed. Now we are moving into the second category of interaction model, which is based on objects. So in this particular interaction model, the interactions are based on objects or artifacts, often with respect to something in the physical world. Remember what I have just said in the earlier slide, that when you move across these interaction models, there is an increasing attempt to look at the physical world, to draw analogies from the physical world. And now we have the interaction model, which itself is based on objects from the physical world. So it is based on objects or artifacts, often with respect to something in the physical world. It is analogous to some specific object or artifact in a particular context. We would soon see a few examples which would help us understand these two lines. Analogous to some specific object or artifact in a particular context. We would soon see example to understand that. It is more specific than interaction models, which are based on activities, and it makes use of something very interesting, which is interface metaphors. Now let us see what are interface metaphors. It would help us understand this interaction model, which is based on objects. So first let us go through interface metaphors. Metaphors in interface design are references to certain aspects of a physical entity or entities in a specific context. Okay, interpretation and meaning. These aspects could be how that physical entity is getting interpreted by different people in the environment. So its interpretation and meaning, its usage, function and behavior, how people are manipulating that. So its manipulation, how does it look, what is its shape and what is its size, and interaction with other entities and with its context. So there are so many of these aspects of physical entities in a specific context, in their environment of usage and deployment, that needs to be considered when it comes to interface metaphors. So interface metaphors, once again, are references to certain aspects of a physical entity or entities in a specific context. These aspects could be interpretation and meaning, usage, functions and behavior, manipulation, shape and size, color and form, interaction with the other entities and with its context. So we are interested in knowing how people make sense of, how do they interpret certain entities or set of entities in their physical environments. Let us see this example to know this point. And their color and form may be the other aspect of such entities. So we all have seen these three traffic signals. They have three different colors: red, yellow and green. And all these three different colors suggest a different meaning altogether. Red color in particular suggests you to halt. Yellow color in particular says that you are ready to go, while the green color suggests you that now it's your time to go, it's your turn to go. So all of these three colors have a different meaning and have a different suggestion to their users. Now you might have seen that in interface design also we use these three different colors for different reasons. So the image next to the signals is the image that is captured from an interface design. Here also you see the red button is meant for a message like that you are closing or you are doing something which has to be done with enough care because you might lose your data. Just like if you pass a signal with red sign on, you need to be very, very careful because it could be lethal. In the same way, the red color in interface design is meant to suggest that once you are exercising this button, you would lose your data, if not saved. You are doing something which is critical to the functioning of the interface. So red button or red color is being interpreted in that sense. Then comes the yellow and then comes the green. They all have different meanings. They all have different level of criticality when it comes to actions that you are performing with the interface. So you see that here we are borrowing, as interface designers, we are borrowing the metaphor of traffic signal and applying that metaphor into the interface design. Now comes the another aspect which is about usage, functions and behavior. We all have seen the use, function and behavior of something like a trash can. It is meant to collect trash and it is meant for its disposal and recycling. So in the same way, if you borrow this metaphor into interface design, you create something like a trash can, which is a normal feature in all the interfaces, something like a recycle bin or a trash can. And even it goes to the extent that you end up using the same nomenclature as well. So if you were to borrow this metaphor into interface design, you create something like recycle bin or trash bin. So this is also one example where the metaphor of trash can from the physical world is getting translated into something like recycle bin or trash can in the virtual world or in the interface design. When it comes to manipulation, shape and size of the physical entity or set of entities in their physical world, gaming per se has adopted it literally in many sense. So for example, what you see on your screen is a console, is a car dashboard where you have a steering wheel and other controls that would be helpful to drive the car. In the same way, if you were to transfer this knowledge of physical world of something like dashboard into interface design, you end up creating something like gaming consoles for different racing games, and they look exactly, literally the same as their physical counterparts. So here the metaphor of a dashboard, of a car dashboard, is brought back into the interface design quite literally. So interaction models based on metaphors inherit or mimic certain aspects of the objects or artifacts in the physical world, but often have their own behavior and properties. They help bringing familiarity with the new interface or new concepts. Let us look at the examples once again. The familiarity of a traffic signal is brought back into interface design as three different colors suggesting three different messages. The familiarity of something like trash can in terms of usage, functions and behavior is brought back into interface design in the form of a trash can or recycle bin. And the familiarity of a car dashboard in terms of how you are going to manipulate it, what is its shape and size, what are the proportions, is brought back into interface design in terms of gaming console. So that is why we are saying that interaction models, which are based on interface metaphors, they help bring familiarity with the new concepts and ideas. And they are either mimicking certain aspects of entities from the physical world, but something that we need to be aware of, that often they have their own behavior and properties. Interface metaphors are extensively utilized in interface design. Okay, so be it scroll bar, toolbar, settings, something like desktop, windows, files and folders, a nomenclature like internet, highway, numbers, accordion menu, cut and paste, drag and drop, calendar, so much of utilization, enormous utilization of metaphors in interface design. What does it essentially do? As designers, it helps us to conceptualize interactions with the interactive artifact. As users, it helps us to make sense of new concepts and ideas. It helps us to articulate and describe different activities that we have performed with the interactive artifact. So it enables a way of describing computing artifact and nomenclature for describing activities. That is very, very important. Brings familiarity and ease of learning, something that we have already understood. It helps user make sense or understand an interactive artifact, help them articulate their actions while they interact. Now, there is something that we need to be aware of as interaction designers. Interface metaphors seems a very interesting topic, and you already know that it is so widely utilized in interface design. But as interaction designer, there are few points of caution that I would like to detail. The first one is decide whether you want to literally translate either the entities or their aspects from the physical world, whether that literal translation is really required. Something that you see on your screen is not hard product. It is an interface of some kind of a equalizer where you have knobs and dials which you can turn and which you can turn clockwise to increase the value, turn anti-clockwise to decrease the value. There is a switch, just like the switch in the physical world. If it goes down, you are making it on. If it goes up, you are making it off. So you have to decide as a designer, how literally do you want to translate aspect of entities or objects from the physical world. You also need to see that once you are designing interaction models based on metaphor, are they becoming too constraining or limiting? So for example, are they able to present new concept and ideas with familiarity? That is where this slide is very, very important. Let me show you once again. Interaction models based on metaphors inherit or mimic certain aspects of the objects or artifacts in the physical world. That is something that we began with and understood that yes, there is an analogy which is drawn from the physical world. See the other point, that they often have their own behavior and properties. So that is why there is a word of caution for interaction designers, that even if you are using metaphors in your interface design, you need to be very much aware of the fact that a good metaphor, when used, enables not only familiarity but also enables learning of new concepts. So it shouldn't just end up being too constraining or limiting. It helps your user understand new concepts. It is very important that you make sure that you have enough affordance, you have enough alternate ways. You also need to be cautious of making sure that by using interface, you are helping your users understand new concepts. And you need to think of alternate ways of sustaining interactions. So for example, it is very interesting. Let me explain you it further. You are drawing analogies from the physical world and you are bringing them into the virtual space of an interface. Something like folders and files, they are analogies from folders and files in the physical world. Now, it might happen that you may be required to find a specific file out of a sea of files on your desktop. So you would end up frustrating your user. So you need to provide alternate ways. So not just use of interface metaphor, not just use of interaction models which are based on metaphor. You have to also imagine and enable alternate ways, because at times the anxiety that user may have with hundreds of files in their physical world, they might carry the same anxiety when they are dealing with so many files in the virtual world. So that is why you need to have alternate ways to enable or sustain interactions, even if you are using interface metaphors. So that brings us summary of today's session on interaction models. Interaction models are operational descriptions of how interaction proceeds. There are two main categories which we had seen. The one based on activities, the first one instructing, second one conversing, third one manipulating and navigating, and fourth one exploring and browsing. Then the second category is interaction models based on objects, and there is an extensive use of interface metaphors in these models. There is one important point which I would like to leave you with, that when you are thinking about interaction models, they essentially serve one purpose, that they help you conceptualize interactions with the proposed interactive product. Okay, so you might be wondering, whether I should use this interaction model or that one, whether I should use instructing or conversing, whether I should use manipulation or navigation or browsing and exploring. It is here that we need to understand that interaction models are not mutually exclusive. In a same interactive artifact, you may be required to use 2 or 3 different interaction models depending on user needs, requirements, and goals. Thank you.